let me just jump into that. So today's topic is about the consensus mechanism, that how blockchain reaches the agreement. So welcome back to the blockchain series. In today's episode, we'll be exploring the fascinating world of consensus mechanism and how they enable blockchain networks to reach an agreement, right? So that's what we are seeing, that it's a decentralized thing and how the consensus is reached. So consensus mechanism plays a crucial role ensuring the validity and integrity of the transaction. So let's dive in. So at the beginning, I will explain the different consensus mechanism. How many are there? So let me share the screen as usual. Just give me a few seconds. Share the screen. Share. Yes, here you go. I hope you can see the screen now. Yes, you can see the screen. To begin, let's discuss the different consensus mechanism used in the blockchain. So two popular mechanisms are proof of work and proof of stake. So proof of work was used. It was used in the initial that is Bitcoin, right? So it relies on miners solving a complex mathematical puzzles to validate transactions and add them to the blockchain. On the other hand, proof of stake involves the participants staking and their cryptocurrency to have chance at being chosen to validate the transaction. These mechanisms ensure the majority of network participate agree on the transaction. So there are few other type of consensus mechanism which are mentioned here, which are offshoot of these two. So mainly there are two, that is proof of work and proof of stake. And we can also see that there is something delegated proof of stake, where the uh, block delegate selection is based on voting. So it is delegated, right? In addition to the proof of stake. So proof of importance, it is POI rewards the users with importance score, which eventually helps them to become the block harvesters. Similarly, there are some more like proof of authority, proof of activity, proof of burning, and the last one is Byzantine Fault Tolerance. So that we'll see in the details in coming slides. So BFT works on system to stay intact even if one of the node fails, with constant communication among the other nodes. So that's how it is quickly about these things. So the next aspect we are going to take care is comparison, right? So when we compare the mechanisms in terms of efficiency, security, and scalability, proof of work, while secure, widely adopted, consumes high energy due to the computational requirement. It needs a lot of computing power. In contrast, proof of stake is more energy efficient and doesn't rely on high computational power, right? So in the recent things like Ethereum and all, so they use proof of stake mechanism, right? Uh, Balancing these factors is crucial for choosing one of the most suitable mechanisms. So that depends on when how the. But generally, I think proof of work is now very less used, right? So it also this slide also shows the other aspects of proof of work. In order to add malicious block, uh, a user need to have computing power which is more than 50% of the network. Then that person can take over, right? And in proof of stake, in order to add a malicious block, the owner user need to have 15% of the cryptocurrency, or the stake should be more than 15%. And at the end, it is the first miner to solve person is given the reward to create a block and add it to the blockchain. And in proof of stakes, there is no reward for making blocks. So validator or the block creator takes the transaction fees, right? So that's how it is. So moving on, as I mentioned, we'll also deep dive into BFT, Introduction to Byzantine. It's a big tongue twisting Byzantine Fault Tolerance. So let me introduce this to BFT to you. Its role in achieving the consensus, right? So BFT is a property of a distributed system that ensure agreement even if there is a even in the presence of faulty or malicious node. It is particularly important in permissioned or private blockchain where the participants are known and can be trusted to some extent. So BFT consensus algorithm provides resilience against the Byzantine faults, where nodes can exhibit arbitrary or malicious behavior. So, in nutshell, it is used in the private networks mostly, and even if any node is not proper, still this BFT algorithm takes care of the overall mining, right? So you can see that there are 0, 1, 2, 3, and some other things are there's not. So it is even if the one other thing like third one is not proper, still the things are getting interactive way, and the reply is sent to the client, right? So that's how the this is shown as a overall structure of the BFT. So just to reiterate, it is used in private nodes, private network, and even if one other thing node is not working, it will be taken care by this BFT tolerance. I don't want to go into detail because we can discuss this in a lot, but it's just an overview of the things what I have given right now, right? Now we will also take a look at the next method, that is two specific algorithms, the proof of stake and BFT. So we are going into a bit more depth of that practical BFT and what is proof of stake, right? So the proof of stake introduces the delegated proof of stake. Sorry, delegated proof of stake. It introduces a reputation-based system where a fixed set of trusted nodes called delegates are responsible for validating transaction. PBFT, that is practical Byzantine this thing. On the other hand, enables consensus in network with a known set of participants, making it suitable for permission blockchain. Means it is a private network and it is a permission blockchain. These algorithms provide different approaches to achieve consensus based on the network requirements. So, if you see here what's happening in the delegated proof of stake, validate, validators taking some of their coins to get picked for adding the new blockchain. These are the validators and function that randomly picks up the validator. So this is the function. Then Joy got selected to add his block to the network. So new block is validated by the validators in the network, right? So everyone validates, and if it is validated, joy gets added, right? So that's why it is delegated because some people are delegated. So that's why it is called delegated proof of network. On the other hand, practical Byzantine fault tolerance. Uh, I don't want to go again, in too much of depth. So this shows how the smart contracts are deployed to the peer nodes, and smart contract is invoked, and the configure operates, that is blockchain operator, and then consensus message flows between appropriate peers to ensure that blockchain transactions are kept in order, right? So this is how it is, taken care. These two things we have learned in very brief. Although these two topics are very vast, and it will take at least 1 hour or more than that to explain each one of them. But I have tried to just give a quick overview of that because every day I have to just finish things in 5 to 7 minutes. I don't want to keep it too large because I'm just touching the points, touching the parts, so just to give you an overview, right? So these emerging consensus mechanisms offer innovative solutions of the challenges faced by the traditional consensus algorithm. Now, I'm just summarizing, and that concludes our exploration of consensus mechanism today. We covered the explanation of different mechanisms, compared them based on energy efficiency, security, and scalability. I introduced you to the BFT, that is Byzantine Fault Tolerance, and discussed the specific algorithm like DPoS and delegated proof of scope, and then PBFT, that is practical Byzantine fault tolerance. We also touched upon the consensus mechanism like POA and POH, and consensus mechanism are very vital for maintaining the integrity and trustworthiness in blockchain. So thank you for joining us today, and be sure to like and subscribe to our channel, and keep watching, keep learning. Stay tuned for the next video tomorrow. Have a wonderful weekend, right? Thank you so much. See you tomorrow.